Okay, so this is a week number 15. This is regarding the Hess law and understand the heat of reaction. And you will see this, there are a series of reaction, which is something about iron oxide. And so let me give you a little general background. So this is iron oxide Fe2O3, also Fe3O4, even FeO, and these are the one that different form of iron oxide that eventually will be reduced into the iron, and that's how people and in this one they use a carbon monoxide as a reactant for further oxidation. Carbon monoxide is oxidized into carbon dioxide, and so this is by oxidating the CO into CO2 you can have an iron oxide into the iron. And the question here is trying to see that, okay, there are three different types of H value, delta H values are given, but they want us to calculate delta H for the following reaction. So let me highlight this. So FeO, and how this is eventually reduced to Fe, and then this using the equation in the above. So where do we find out FeO? Here, right? So, and the idea here is the scientific idea is H is state function. Okay, so therefore delta H is only depending on the final minus initial, and you can have any intermediate. I mean, I'm just putting as an A, B, eventually I, right? So there are different types of route that involve the delta H to get into the overall H here. So what am I saying here is from the FeO, let's imagine that instead of going directly reduce it into iron, and FeO can be reduced into Fe3O4, and then that Fe3O4 can be further reduced into Fe2O3, and then Fe2O3, which is the same thing, can be now further reduced, okay, to the Fe. So I think I have to make a correct statement. FeO can be oxidized to Fe3O4, and Fe3O4 can be further oxidized into Fe2O3, and Fe2O3 can be finally reduced into Fe. So that's my three steps, and then I can say that's 1, 2, 3. Right? And then so let's start from here. So I want to start using this FeO CO2 going to Fe3O4 CO. Okay, so this is, I guess, a number 3. Okay, this is let's say this is a 1, 2, 3. But what I need to do is I need to Fe to make it. I need to multiply by 3. So what I did here is I flipped this equation going to the reverse way, and I also multiply by this. So therefore, my first delta, I guess first step, 1, I guess, let me just say that just say 1. First step is 1 over, and then which is, and then the 1 over 3, and then multiply by reverse, which is a -1, and on delta H number 3 over there. Okay, so which is shown up here, number 3 over here. Let's just say 2. This is a 1. Okay, so once I have that one done, now I have FeO plus 1/3 CO2, 1/3 Fe3O4, 1/3 CO. Okay, so I have that part done. And then this Fe3O4 has to be removed in this equation. So I need an Fe3O4 in this equation, which is in the second equation above. So let me start with just copying down, but in a reverse way. So this one I'm just considering this backward reaction and showing up there. CO. So this is 2 times Fe3O4 CO2, and then 3 times Fe2O3 plus CO. Okay, so this is an equation, the second equation there. And once again, this is my first equation, and that is my first delta H in the first step. The second step is now I need to get rid of it. So therefore, this one, I use a different color just to highlight. Okay, multiply this by 1/6, right? So that will naturally have you 1/3 Fe3O4. I just want to highlight this one, and then maybe I can go back to the normal colors. 6 CO2 is now 1/2 Fe2O3 plus 1/6 carbon monoxide, and that will be my second equation. And by adding these two equations from the top to the bottom, and what I can see that is this equation is gone, right? So you can imagine yourself adding these two together. Okay, so that's why I multiply by 1/6 to get rid of some intermediate products. So by doing so, my delta H for the second step, which is 1/6 once more, and I use essentially the reverse, right, going in the backward. So therefore, I will need to multiply by half, inverse the sign, and the delta H for the second one, right? So this is what I have, and for my second step for here. And so then, what do I have now? Let me just highlight. So now I ended up dealing with this one only, and then that's the one. So now I have the last piece of puzzle, which is an Fe2O3 can be used. So my first job is just to write it down as it is. Fe2O3, 3 times CO, 2 times Fe, 3 times CO2. Okay, so that's my first reaction, which is showing up. The Fe2O3 is right there. So I do the same thing. My goal is trying to, I guess, get rid of this, what quote-unquote intermediate, so which is a half is here. So because of that, I just want to multiply by half, and by doing so, you will have half Fe2O3, 3/2 CO, Fe, 3/2 CO2. Okay, so that is your third equation. And then this one, by doing so, I was able to do the following. I will get rid of this, right? And then this one allow me to saying that, okay, this is a third step, which is an H third step. That is 1/2, and it is the same direction, so you keep the same sign. And then this is the first one, right? So first one right up there. So, and then you need to kind of tally up on the and the values are shown up here, and then you add it up, and then you will see that Fe. So I'm talking about this equation, this equation, this equation. Okay, so you add those three equations, and that will give you FeO. And then if you look at the carbon monoxide, there's 3/2. There's 1/3. This is 1/3. If you add them together, there will be a half. So only CO survive, and which is a good thing. And then the only thing that survives in this kind of the box, the equation, the Fe, and then the CO2 is 2/3, 1/6, 1/6, and the 1/3. So that's also naturally same as the CO2. Okay, so this final equation that we want to solve it for this delta H is essentially delta H for the first one, delta H for the second one, delta H for the third one. Because by adding these three equations together, eventually, which is the general concept that I explained it before, the first step, second step, third step, right? The difference between first and second and third, and that's what you have. In the practical sense, you will have 1/3 minus 1/3 delta H for the third one. Second one is minus 1/6 delta H for the second reaction, and the last one is half of plus delta H for the first reaction that is shown up, which is I noted here as those three equations shown up. And if you do that, and you will get minus 16.8 kilojoule. Okay, so this is my delta H is minus 16.8 kilojoule. For the last note that I want to make sure that I give an explanation here is, please note that this is a delta H for this reaction is particularly true based on the way the reaction is written. Okay, so remember that this one we do not say per mole, right? There's nothing like that, because the way the reaction is written this way, and that is corresponding to this way. So, but by understanding this, I can see that to generate iron, 1 moles of iron, and from the 1 moles of FeO, that is a delta H reaction, which is also can be understood as an exothermic reaction. Okay, thank you for your attention.